Hello guys, welcome you all for this end-to-end session on AIML, where we're going to learn everything like how this AI works, how every background of AI, how the model is built on what is a theoretical concept, what is the mathematics behind it, everything that we're going to learn to become a successful data scientist. I will not say successful data scientist. In the data science field, you can become very successful. You can have all the ideas of how the models are working, how they are building model, AI, ML, everything end-to-end we're going to learn. Okay, so welcome you all once again. So before going for this session, as always we are saying, like, please guys, please make sure that you guys are watching all the previous video, and then you can just come to this video, because like you guys doesn't know what we are talking of. So make sure that you guys have watched all the previous sessions, so that just come to this session, so you can have a better understanding of what we are talking. Okay, in the previous session we have introduced a new unsupervised learning technique called as dimensionality reduction, where we have looked into two different algorithms. So today we're gonna continue that. Okay, so now let us directly dive deep into this session. Okay, first thing that we are having today is one of the dimensional reduction technique is t-SNE. Okay, it's a T distributed stochastic neighbor embedding. That is, here it gonna form the clusters based on the t values. Okay, t-SNE. Okay, it is a non-linear technique. t-SNE is a non-linear technique that preserves the local structure of the data while reducing its dimension. So however the data can be projected, it not gonna assume the data is in a linear form. No, it will do dimensional reduction in the non-linear format itself. Okay, that's a major advantage of this method. Next is similar preservation. So similarity preservation, the reason is t-SNE aims to place similar data points close to each other in the low dimension space. What it does means, it also do a clustering inbuilt. Okay, what are the, first of all, it will reduce the dimension from like 1000 to 10, and then from the 10, what happens means it will try to create a clusters out of it. So it does the dimensionality reduction and also cluster the data points. Finally, visualization. t-SNE is commonly used for visualization, allowing us to see the complex relationship between the data points. So as I'm mentioning, right, so whenever the day we are having huge volume of data, we need to go for a visualization so that we can get a better understanding of what the data is. Okay, so this t-SNE, I will say, it's a one of the very nice and super looking algorithm, which makes the things very easier for visualization. So I will say it's a it will look very perfect. Okay, when you go for t-SNE. Okay, the dimension of the data can be anything. Okay, so yeah, that's all about this t-SNE. So it's one of the dimensional reduction technique. So yeah, sir, over to you.
Yeah. So T distributed stochastic neighbor embedding, t-SNE, we call it in short form. So it is a dimensionality reduction technique, nonlinear technique. It is okay. So t-SNE is nonlinear technique that preserves the local structure of data while reducing the dimensionality. Again, we are learning right now dimensionality reduction, so these techniques are for that only. So, second is similarity preservation. So, t-SNE aims to place similar data points close to each other in the low dimensional space. So that is what this technique is. The objective function of this technique is to reduce the dimension so that in a low dimensional space, so that it is optimized and there is performance optimization. And then visualization in t-SNE is a commonly used for data visualization, allowing us to see the complex relationship between data points, because there would be a lot of data, guys, a lot of data points. So it will help us to show the important ones which are relevant for that particular objective function and for the model. This is how we use t-SNE as a dimensionality reduction technique.
Yeah, so that's the thing. So let's move on to the next algorithm. Okay, we are completed with the algorithm. Okay, so the thing is, like, you can see, right, so we are having PECA and LDA. These two are like linear models for dimensional reduction, whereas this t-SNE is a non-linear model, and we are having one more thing that is called a sorted encoder. That is also a non-linear model. It's a simple thing, guys. So when we are considering this LLM, right, it is built on top of this autoencoders. Okay, so they are also a non-linear kind of unsupervised tech. Okay. So let's move on to next. Applications of dimensionality reduction, I think we have introduced this in the first session itself. First thing is image recognition. It reduces the dimension of an image feature for faster and more effective classification. That's true, guys. Consider we are having a huge number of pixels for an image, then it becomes very complex for us, and also it is very resource taking, right? So using this dimensional direction, we just nullify these two things and can do a great image recognition. Okay. Next is text analysis. Represent text document in a lower dimension space for topic modeling and document clustering. Guys, these two things till now it is very important and very booming field. Okay. Topic modeling, whenever you are having some models which can create a topic out of this like a huge volume of data, that is called as topic modeling. So what happens means it is reducing a dimension, right? From a higher volume of data, it is reducing to a volume like a text, okay, like a title. Okay, that's the thing. Another thing is document clustering, where we will be a huge volume of documents and we are just clustering it out like using t-SNE anything. Okay, so these things are very helpful by using dimensionality reduction. Makes use of it aids the help of dimensionality reduction to do text analysis. Next, we are having medical diagnosis. Reduce the dimension of patient data for disease prediction and patient classification. That's true, guys. Consider we are having heart disease prediction data set. You just go for the Kaggle. Kaggle is a website where we are having open and public data set, and just type on heart disease prediction. It's a data set that we will be having. It will be having more than 10 plus features, I think so. We doesn't need all the 10 plus features. We just need 3 to 4 features which can do the classification of heart disease. Okay. So dimensional detection that plays a role. So that is what medical techniques is. Next is data visualization. Creating insightful visualization of higher dimensional data to uncover hidden patterns and relationships. Because consider if we are having 1,000 columns, what is the possibility of just displaying the 1,000 columns in 1,000 columns with data set in a single sheet or a graph? Not at all possible, right? So this data, this dimensional reduction, what happens means it will convert the 1,000 features to the only most important feature. Consider it's a 10. Okay, now it is we are able to create a data visualization. So, yeah, these are the some of the common applications that we are having in dimensional reduction. Yes, sir. Over to you.
Yeah. So application of dimensionality reduction. So we can use it in image recognition. Okay, reducing dimension of images, features for faster and more efficient classification. Okay, and then we can use it for text analysis. Represents the document that have low dimensional space for topic modeling and document clustering. We can use it for medical diagnosis, reducing dimension of patient data for a disease, predicting the patient classification. So data visualization, we can use dimensionality reduction. Okay, creating insightful visualizations, high dimension data to uncover hidden patterns and relationships. So highlighting the important aspects of the data so that we can make decision. Ultimately, whether machine makes decision or we make decision, data is always we build always these models so that we make right decisions with right precision and accuracy, and that's what is the ultimate objective, whether it is done by machine itself through automation mode, or it is done by scientists or data scientists or AI researchers. So that is the objective. So whatever is done, then data visualization, it helps us to show the right data and the hidden patterns and the relationships. This is how these are the applications of dimensionality reduction. Let's move to the other slide.
Yeah, sure, sir. So moving on, let's see what we are having. Yeah, challenges and limitations. Okay, so any technique we are having, we're gonna have challenges and limitations. Okay, first is information loss. Dimensional reduction inevitably include some loss of information, which can affect the accuracy of downstream tasks. I don't think like it's a major problem, but like there will be some loss. Okay, consider like we are having 1,000 features, we are just reducing to 10. That will be loss, right? So that's the thing. So we're gonna have some loss. And choice of technique, the choice of dimensional reduction techniques is crucial and can significantly impact the result. Yeah, you need to specify what kind of dimensional reduction technique can your data can apply. Okay, like whether you need to go for a linear models like PC or LDA, or you need to go for a non-linear model like autoencoder or TSA. Okay, you need to specify that. Okay, next is parameter tuning. Higher, like many dimensionality reduction techniques require careful parameter tuning to achieve optimal performance. Yeah, that's true, because like whenever you're training a model, thousand components has to be converted to a 10 components, right? That requires lots of fine tuning. Okay, like whether we need to take this column we need to merge, or we need to generalize five different columns, like those things we need to fine tune. Okay, then um, interpretability, that is a major problem. It can be challengeable to interpret the reduced data and understand the meaning of new features, because consider we are having 1,000 features which can represent the target value. Now we are having only 10 features, then the explainability of data reduced, right? We cannot say, okay, these are 10 features and this can do. Okay, we can say, but like overall using 1,000 data representing a target value is much easier for the client or anyone than using 10 data to represent the output, okay, or target. So these are the challenges and limitation. Okay, so yeah, sir, over to you.
Yes. So challenges and limitations, guys. First is information loss, because it's a common sense, guys. When you reduce dimensions, you might lose some information, but you have to choose the right data, like right features to reduce dimensionality. So that is very important. Huh? Dimension reduction, it there would be a loss which can affect the accuracy and downstream tasks. So then choice of technique, the choosing the right technique for dimensionality reduction is a crucial. It has significant impact on results. So if you're using PCA or you're using TSN or whatever techniques you're using, you need to know what is the limitation of it, what are do's and don'ts of it, so that don't use any technique. For experimenting, when you're learning, you can use and test and see how it performs, what is the behavior. But when you're working in an actual environment or actual team, when you're working on a real time case, a real project, so you need to know before that. Okay, parameter tuning. Many dimensional reduction techniques require careful parameter tuning to achieve optimal performance. So we need to do the parameter tuning, okay, that will help us to optimize these are the challenges. Huh? So so we need to carefully pick the parameters for tuning. Huh? We cannot pick any parameter. Okay. So interpretability. So there can be a challenge to interpret reduced data and understand the meaning of new feature. So that is a challenge, and there might be a different, you don't know how machine will behave or a model will behave. So you need to understand these are the challenges for the dimensionality reduction techniques. So keep these challenges and limitations in your mind. Let us move to the other section.
Yeah, so moving on, conclusion and future trends. So the thing is, dimensional reduction is a powerful technique with a broad application in machine learning and data science. It's true, okay, because like whoever like reducing the computation, as sir and me are mentioning in the from start. Today the computational resources were like high demand. You guys cannot get a computational resource for freely using it. Okay, that's the reason this dimensional reduction is powerful technique with application in machine learning and data science. Future trends includes development of more sophisticated non-linear techniques, okay, that increase the focus on interpretability and then integration of this dimensional reduction with other machine learning tasks. So major thing dimensional reduction is going to do means it's going to reduce the computational complexity and the resource, so that the problem that we are having today can be somewhat be reduced. Okay, so yeah, sir, over to you.
Yes. So conclusion and future trends. So dimensionality reduction is a powerful technique, guys. It has a broader application in machine learning, data science, and I would say AIML Pro end to end. Future trends, including development of more sophisticated non-linear techniques. You will have some other techniques which will be invented. So there is a increased focus on interdependability and the integration of dimension reduction with other machine learning tasks. So you first thing is whenever you get any technique are you are learning about it, try to experiment, learn properly end to end 360 degrees so that you know limitations, do's and don'ts of it properly end to end, so that you're consciously aware, you're uh, completely aware about where to use, where not to use, what would be the limitation if I use it here, if I use it there. So understand it properly, and all these sessions watch all the sessions 5 to 10 times, do a reinforced learning, and also absorb the information, digest the information, and apply to all the assignments, and write in the comment section what have you learned, what is your objective function of learning these sessions, and also keep continuously learning, and subscribe to our channels, and also press the bell icon so that you will get notification for each session. Thank you so much.
Yeah, guys, so that's the thing. So yeah, guys, so that's all we are having for today. So guys, just understand, like as sir is mentioning right in the beginning, from beginning, okay, we are doing in a breathwise manner, we're going to do in a depthwise manner. Just understand the theoretical concept. So today we have completed a dimensionality reduction. It's a, I will say it's a quite challenging and tricky concept. If you guys have any doubt, just ping in the comment section. We are here to help you. So hope you guys have enjoyed this session. We will meet in the next session. Until then, bye guys. Take care. Bye.
Bye bye. Take care, guys. Do reinforced learning and give us feedback how we can improve each session for you guys. And we are there to serve you, help you continuously. So write in the comment section. Thanks.